Okay, and a brief review on trigonometric functions. This is by no means a complete or thorough treatment of trigonometric functions, just kind of the basics that we will need to remember when we proceed in our studies in calculus. First of all, remember that 180 degrees is pi radians, and then so as a result, if you want to know, say, if you have x degrees, to get that into radians, you would need to multiply by this. The form of 1 that we would use is there's 180 degrees in 1 radian, and then our result would be some number y radians. Just as a quick review. Going on, we first introduced the trigonometric functions sine, cosine, tangent, and their reciprocal functions, not inverse functions, on a triangle. So defining for an angle theta down here, the adjacent side we would call x, the opposite side from theta is y, and then the longest side of the triangle we just call the hypotenuse. Okay, so sine is opposite over hypotenuse, adjacent over hypotenuse. For cosine, tangent is opposite over adjacent. Some of us might remember SOHCAHTOA, where that tells us, or it's a mnemonic to help us remember the order of the sides. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. And then from there, we kind of extended our definition to having any angle that was not an acute angle. So, for example, we could be in the second, third, or fourth quadrants. This would be our standard one where we'd be in the first quadrant. And then looking at defining the trigonometric ratios here, x and y. X would be negative here. Both x and y would be negative in the third quadrant, and then in the fourth quadrant only y would be negative. And so we can actually generalize the definitions that we had above here, remembering that r's r we get by the Pythagorean Theorem. Just as a quick reminder, the Pythagorean Theorem is a squared plus b squared plus c squared, or equals c squared, and that's on a triangle where we have the legs, the two shortest sides being a and b, and c being the hypotenuse. And I think I said on a triangle, I meant on a right triangle where we have an angle that is 90 degrees. Okay, so these things we will be using quite frequently, sine, cosine, and tangent more so than the other trig functions. And we can actually get some nice, if we get some nice known values for sine, cosine, and tangent at various angles. This is by no means complete. You can certainly just look up angles for sine, cosine, and tangent, and you should get a table, or easier, just plug it into your calculator. We also talked about in pre-calculus about the unit circle, which is a circle of radius 1, and on the unit circle, the coordinates, if we know the coordinates, the x value corresponds to cosine and the y value corresponds to sine. So this actually gives us a nice, quick, and easy reference to know what the cosine value and sine value is at, say, 60 degrees, at 210 degrees, at 300 degrees, etc. Okay, and again, you can either take this picture, or if you just Google unit circle trig, you should be able to get an image of a picture like this. Okay, and with these trig functions, you get a lot of very handy properties. So domain for sine and cosine is all real numbers, and their range is from -1 to 1. So whatever we get out here for sine, that'll be between -1 and 1. Sine, cosecant, cotangent, and tangent are all odd functions. Remember, or look back at the functions video to recall what, or actually I think it was in the polynomials video, to recall what odd meant. And then cosine and secant are even. There are many identities. In particular, you should know the Pythagorean identities. Pythagorean identities, and the reciprocal identities. Okay. And then the last big property that we're going to use with a lot with great frequency is the period property. So sine and cosine both have a period of 2 pi, and then their reciprocal functions do as well, while tangent and cotangent only have a period of pi, meaning that outside of the period they actually repeat the values. So for example, down here, I have this big huge angle. If I can get it to be somewhere between 0 and 2 pi, I can actually compute the value. So one way to do this is to subtract 2 pi continually until you get a known value. And that's okay. It'll take us a while. But what I'm going to do is I'm actually going to represent this using division. So if I divide 6 into 32, it would go in there 5 total times. So I'd get up to 30, and then I'd have 2 as a remainder. So I'd have 5 plus 2 over 6, and I have that as pi. Okay. I can write this as sine of 5 pi. I'm just going to distribute that pi, and then I'm going to write this as, simplify that as plus pi over 3. Now I need to think how many total 2 pi's do I have in this? Well, I have 5 pi's. So I have 4, so I can remove 4. So this is equivalent to sine of just pi plus pi over 3. Okay, again, because the period is 2 pi, I can remove any multiples of 2 pi that I have. And so continuing the simplification, I have to add these. So this is equal to sine of 4 pi over 3. And if I go back on my unit circle, 4 pi over 3, that is going to be, well, would be 3 pi over 3. An additional one would be right over here. I look at the sine value, the y value, and that's negative square root of 3 over 2. Okay. Now you could also punch this in your calculator or Wolfram Alpha. If you do your calculator, though, please make sure that you are in radians, because that is, if you have a value inside of a trigonometric function that involves pi, that automatically refers to radians. Okay, so that's that one. Now for cotangent, remember that the period is pi, so I can remove any multiples of pi. I need to first do the division, though. So cotangent, and I'm going to represent this. If I divide 4 into 22, it goes in there a total of, not 4 times, 5 times. And then I have 2 left over, plus 2 over 4 pi. Okay, distribute. Cotangent of parentheses 5 pi plus pi over 2, again simplifying. Now I can just remove all those completely, because any multiples of pi, that'll just give me the same value. So this is equivalent to cotangent of pi over 2. Okay. Cotangent is cosine pi over 2 over sine pi over 2. Okay. Cosine at pi over 2, 90 degrees, is 0. Sine is 1, so I just get out 0. Okay. And so that's a quick recap on periodicity, or using the period of a function. Okay, and a couple other problems that we're going to see, or that we could see, is if we need to determine the exact value of the trig ratios if we're given 2 conditions. So we know that the cosine is negative 15 over 17. So cosine, remember, if we're thinking on the unit circle, that would, to be negative, that would mean it's either in the second or the third quadrant. Okay, but now we also have to incorporate the other condition where tangent is greater than 0. So tangent, remember, that's y over x is greater than 0, or sine over cosine, if you want to think about it as sine theta over cosine theta. And so if we know cosine is negative, in order to get a positive value, sine also needs to be negative. So the y value needs to be 0, or greater than 0. So we're going to end up being in the third quadrant. Okay, so I'm going to erase that for right now. As long as we know that we're in the third quadrant, I can draw any arbitrary angle. Actually, I'll use green. So if I know here, this is going to be my angle theta. I can form my triangle. Okay, now cosine, we said, was x over r. So that means my hypotenuse is 17 and my x is a negative 15. Okay, negative here, remember, a side length can't actually be negative, but we're saying negative due to direction because x is on the negative. We define to the left of the origin to be a negative direction. And then after you do the computation, this, with the Pythagorean theorem, again, this is right angle, or right angle. This will be 8, but we have to make it negative due to direction because we define down to be a negative direction. Okay, and so we can form the other trig ratios here. Sine of theta, that'll be, if this is my angle here, sine is going to be the opposite side over the hypotenuse, so that's negative 8 over 17. Cosine we already have. Tangent is going to be opposite over adjacent, so 8 over 15. Cosecant is going to be the reciprocal of sine, so that's 17 over minus 8. Secant is the reciprocal of cosine, so that's 17 over minus 15. Cotangent is equal to 15 over 8, the reciprocal of tangent. Okay. All right, and the last quick thing that we're going to mention is the graphs of sine and cosine. So sine, they both look very wave-like. Sine begins at 0, increases, decreases, and ends up at 0 at 2 pi. Cosine, it starts up at 1, decreases to 0, and increases again. Okay, and then we may have some transformation problems with sine and cosine. And we define a few key terms. Amplitude is given by the absolute value of a in front of sine, or similarly cosine. Period we define as 2 pi divided by the b value, or our horizontal scaling factor. And then the phase shift is just how far we move left or right, so it's our horizontal shift value. Okay, and all of that is a very brief review of trigonometric functions.